Okay, number 1. Restrictions. So we know with radicals, the big idea is the square root of a positive works, the square root of 0, that's good. But the square root of a negative, not good.
We're doing a recap.
Okay, so what values are not good or which ones work? What do you want to say here? What do we know about x here?
Over that one right there. X is not equal to 8.
X is greater than or equal to 8.
X would have to be bigger than or equal to 8. You could have also told me this. X is not allowed to be less than 8. That's the same thing, right? So either one. This is a very common mistake. I get x cannot equal 8. That is an error. You would get 0 out of 4 on your test if you think that you need to write like that. Because I have 4 questions. If you do that mistake 4 times, you get 0 on the whole outcome. Right?
L.
So don't do that.
Can you both of them or can you do one?
Just one or the other. So
But if you do both, you get extra points?
no. So you're either telling me you're making sure x is bigger than or equal to 8, or understanding that x cannot be less than 8. Okay? What if I wrote this?
You just have to flip the sign around.
X has to be less than or equal to 10.
X would have to be under or equal to 10. For instance, 4 works because 10 minus 4 is 6, and that I can square root a positive. Okay, multiplying and dividing. So this could be a question on your test. What would you do if you see something that looks like this, where a binomial is squared?
You write it.
Yeah, you can't cheat. You need to write it out twice. Because 2 binomials will make you do what in your multiplication? FOIL. Do I get to cheat and just do the FLA? No, because they are not conjugates of each other. They're the same thing. They're minus minus. That's the same thing, not opposite. Okay, first times first makes a 4, and then root 5 is just the whole number 5. If you happen to write root 25, that's fine, but eventually you would have to change it though for me. Outsides, in the front is minus 12, root 5, root 2, so root 10. Insides, in the front of those is a minus 12 again. And then a root 2 and a root 5, root 10. Last, we have a negative 6, negative 6. So it's positive 36. The square root of 4, or just a 2.
That's what the perfect square.
Okay, so this is 20. Anybody know mental math what 36 times 2 is? 72. Okay, so I'm going to put 20 and 72 together because they're like each other. So that would be 92. And these I can put together because they're both root 10s. So I have minus 24 root 10. Some of you have been asking me that yours looks different. So if yours looked like this, that's good too, right? It's just writing it opposite. Obviously, as long as you see that this is negative and negative, right? It's the same thing. Okay, rationalize the denominator. So that would be to get rid of the denominator on the top or bottom? Bottom. We don't like fractions with a radical in the bottom. So when I look at this bottom, it's a monomial. So what's the trick? You multiply by just the root. Which means the top is the same. Okay, so this would create a binomial monomial. So that's how I would have to distribute that. So I'm getting root 42 minus 4 root 30. That's good? Bless you. On the bottom, there is a 2 for the whole number. And then a root 6, radical part makes a whole number 6. Okay, on your test, everything, I put it at the top, everything must be in simplest form. So if this was like a 36 in the front, whatever, that you could divide by 12, you're going to do that. Here I can't, right, because it's a 1 divided by 12. That's not going to make something simpler. But let's pretend this was a 36 in the front and this was a 48. Then you can divide those two numbers by a 12. You can do that.
So then you keep 12 on the bottom?
Like if you had something like this is what I'm saying. Like if I had that, do you understand how to reduce this? So you would take this just to be 3, and then you would take that. Okay? So if you can on your test reduce something, make sure you are reducing it, because I have directions. You have to have simplest everything or else you get deducted.
And you do not keep the 12 on the bottom then?
No, because I did this.
Okay.
Do you see it? I did a 36 divided by 12. So then I did that to be a 3. Let's check. 42, can it break down? Is it divisible by 4, 9, 16? But 2 is not a magic number. Yeah. No. Is 30? Is it divisible by 4, 9? Nope, so I leave it. Okay? I feel like the ones that are trickiest is when I have you get a root 20. Because root 20 can break down. What about a root 18? Yeah. Those ones sometimes people miss. Okay. What do you do to get rid of the bottom when it is a binomial term?
You multiply by the conjugate.
Multiply by the conjugate. So how do I write the conjugate of that bottom? So I rewrite it, but put a plus sign. So it looks the same except for one has a plus and one has a minus. Okay, the top, I'm going to leave you to it. You're going to have to FOIL that whole thing. There's going to be 4 parts of it. On the bottom, what is special about conjugates though? You can skip the OI part of it because they would cancel each other. Okay, so I want you to work on that and I'll work on it and see if we match. Okay, my answer is this right now, but on your test, this answer will lose you a half of a point. This is where I said you always got to go through and check at the very end.
9.
This one. If I say simplest form on the whole test, that is not in simplest form. Okay, so I'm just going to do this above here. How do we break 18 down then? Root 9 and root 2.
Yeah, I know. I don't know what's going on right now.
Okay, so 18 we changed into a root 9 times a root 2. Then the root 9 can become a whole number 3. So now it's 6 root 2.
Then technically they can all be reduced.
Nope, because I can't divide 15 by any magic numbers.
Where are the magic numbers? Let me put it right
4, 9,
How?
16, 25. Because I can break down the radicals by those magic numbers. So like 15, for instance, if somebody's trying to break it down into a root 5 and a root 3, well, what does that help? Because I can't break, root 5 is nothing to me, and root 3 is, right? But breaking this down into a root 9 helps me, because now that can turn into a different whole number. Okay, so that is this skill. So there will be a few spots on your test where it's just going to randomly happen, so make sure you check. Okay, so magic numbers. 75 is divisible by what magic number?
4. 25.
25 times 3. 25 times 3 is 75. So the root 25 times the root 3 is therefore root 75.
Yeah, I said the root 25.
And then 5 root 3. Okay, 252. You probably don't know that one, so it's okay to jump to your calculator. What do we got?
15. 9. 4. No. It is 9. It is 9.
No, it isn't.
It is, but I'm not going to use it. I'm going to use something bigger. You know why? So if I did 252 divided by 9, I get 28. But then 28 also has a magic number in it. 4. So what happens if you divide it by 9, and then this is divisible by 4? What could I just originally divide it by? 36. Okay? So if you can divide something by 9, but then you look at the number and it's still divisible by 4, 9 and 4, that's a 36. So it's 36 times 7. Okay? Like I said, you're always trying to get to the highest magic number.
Okay, you said it was 25. Now I'm doing wrong.
And if you had done 9, that's fine, but then the 28 you're going to have to break down. So now you have 2 breakdowns instead of 1. Okay. 108. What is it divisible by?
Like a lot of numbers. 9.
9?
9.
Okay, again, that's good, but now 12 is divisible by 4. So now
36.
it should be divisible by 36, so I'm going to go back and check.
Oh, wow. Look at that. Yeah.
36 times 3 is 108.
Dumb. I'm glad my 3. I think
Okay? Because 108 is the same thing as writing 36 times 3. So now I just separated them. They're still in the radicals right now. I still have this is still root 108 at this point. Okay, I'm going to change root 36 would be a whole number 6. So that's good, minus 24.
Yeah.
See where I'm getting that from? Okay, 28 is not divisible by 36.
4.
28 is divisible by 4. What do you got? 4 times what?
7.
4 times 7. Do you always notice how I'm writing the magic number first? I don't, it just helps my format. Bless you. So root 4 is a 2, so I get minus 10 root 7. Now what?
Now you can put the 6 and 29.
I can put
Oh my gosh, it's all together.
those together. 5 subtract 24.
Is negative 19.
Negative 19 root 3.
Yep.
From the 10 and 6.
And then I can put those together because they both are root 7. So altogether that is minus 16 root 7.
Yeah, this is
No, but I have some on your test.
There were problems in every single unit. It's just like when math teachers lie to you and try like, oh, this will be useful when you get out of high school. And when you get out of high school, you never use it again.
Okay. What would I do to this equation? What would be my first instinct to start?
Zero? You have to. I don't know.
You have to square it.
Your first
I'm going to square both sides.
size. Why?
Get rid of the square roots.
Oh.
It doesn't help me to move something over, right? Because that just looks way more complicated. I have some radical minus some radical. That just.
What? It says get rid of the square root.
I'm going to square both sides.
I only said 10 seconds.
Okay.
We're thinking what happened to you.
What does the whole number become? 9. What does the radical become? 2x plus 6. Because the squaring of the square root, what? What happens when you square a square root?
It just gets rid of the
It just gets canceled, and then you get what's underneath, right? Equals. So, by the way, if I wanted you to see this squared, this is what I'm doing, right? I'm squaring something, I'm repeating it. So what's the whole number times the whole number? 16. What's the radical times the radical? X plus 4. Okay, the concept of the same radical times the same radical, right? Root 500 times root 500 is just 500. Okay, this is all old math. What do you want to do?
You can put it into brackets.
Distribute. Distribute property of polynomials. Algebra branch, we have how many variables? We have one variable, so we're going to isolate it. So we're going to group the x's together. So minus 16x is what I picked. Minus 54, right? Okay, you cannot forget to do this. Check your answer. So I got 5. Okay, let's plug a 5 in. You ready for some quick mental math? What is 2 times 5?
10.
Plus 6, 16. What is 5 plus 4? 9. So that's what I would have if I plugged it in, which would be 3 times 4. And this would be 4 times 3.
12 equals 12.
Our answer is good.
Oh, wow. So it seems to be the same on both sides.
Yeah,
Pretty much.
because sometimes it gets thrown off with some negative stuff.
12 equals 12.
Okay,
That's why I never wear a hood, because my hair's too thick. It's like a potato.
next. What do you want to do here? I'm going to isolate. Subtract 5. Isolation stuff. Get the radical alone is what you need right now.
Exactly.
So I'm going to get rid of the 5. So 8. And then I'm still going to get rid of the 2.
Let me square. I thought that too.
You can square it. If you did, you would get... Is this what you did?
I didn't do that because you did the wrong thing, but
I'm isolating the radical. Here, on this question, it wouldn't help me trying to isolate the radical because dividing by 4 is just going to create a fraction on that side. Didn't really help me. Okay, so if somebody just squared on that side, that would be fine as well.
But now we have to square, correct?
Yes, did you see here? I squared the whole number 2, and then I squared the radical by canceling it, and I squared the 8.
Keep it, but now we have to.
Now, this would be the method that I would have picked, and now I square both sides. So 2x minus 4, because that cancels, and 16.
But you have to check.
Check, I got 10. So I'm going to go 2 root something plus 5 equals 13. Okay, 10. 2 times 10 is 20. Minus 4 is 16. 2 times 4 plus 5.
13. Oh my goodness, we're doing this.
Yep, that is working out.
13 equals
Next year we're gonna go 2 plus 2, just 1.
Okay. Same concept here, so I'm going to minus 10. And divide by 4. Then what?
Oh, it's no solution, but it's a negative 2.
It's a no solution. Because in math, if you have the square root of something, what's implied?
It's positive.
The positive root. So if you take the positive version of a radical, could it ever equal negative 2? No. I'm going to pretend I forgot. You ready? I'm going to pretend I forgot. This is not what I want you to do, but someone's going to do it anyway.
Yeah, probably. I'll volunteer to be. Voluntold.
Somebody's going to do this because they're going to forget. Okay. So if somebody's going to be like, I'm going to square both sides. This also really bothers me. This is wrong when they write it like this. If I am squaring something, I need to.
Bracket. Or you can get marks off the bracket.
If you ever square a negative value, yes.
Could you put brackets around like anything? Like, can I put brackets
Yes.
around negative? Do you only have to put a bracket around it when you're squaring like it's negative?
Can I put a
Yes.
bracket around that X? I just feel like it's a little out there. But like,
You have to be careful. If, like, for instance, if you put a bracket around -7, now you're doing an x times -7 instead of x subtract 7. So you.
I feel like brackets are easier.
Okay, so let's pretend I got it wrong, and I got 11. Okay, but what do you have to do?
Check.
Check. Okay, so if I'm checking, I plugged it in. What is 11 subtract 7? 4. Root 4 is 2. Then I get 8 plus 10 equals 2.
Okay, maybe they wrote it wrong because we got a number. We got a good number.
Does that also line up with my idea that there's no solution? Okay, so see, if you forget and you accidentally went through and you did math work on it, instead of just remembering at this point no solution, if you check your answer, you'll notice that there is no solution. It didn't work out. Okay, next, last one here. I'm going to -3. How do I write that? X minus 3. I get mistakes over there all the time of something like -3x. You're not timesing them. You're not timesing them. You're subtracting and you can't put them together. Now what do I want to do? Square both sides. What do you need to do if you're going to square that side? You're going to need to understand you're squaring the unit. Biggest mistake on the test. And by the way, if you make the mistake, your quadratic is not going to be factorable and you're going to be up in the tree thinking how to do this. Okay, I have it obviously set up that to do it correctly, you're going to end up with something that I can probably simple trinomial. Okay, so there's your hint. If you're like, oh, this is not factoring, you probably did something wrong. Obviously, there's the quadratic formula, but I'm telling you that I did make it factorable. Okay, so squaring the square root, that's just a cancel. Squaring as a binomial, you get a trinomial. Okay? So that's what people are missing out on. I get all the time just that because they just square each thing individually. It's not squaring individuals. Okay, what do you do at this stage? Equals 0. X squared is the boss, so it's going to stay. I'm going to do what else here? I'm going to subtract x. Subtract 3. And does it factor? Do you have something that multiplies to 6 and adds to 7 somehow? 6 times 1, negative, negative. What should you do? Check. Okay, I'm plugging in. So that's what it would look like. So here I plugged in the 6, here I plugged in the 1. So the 6 looks like it worked. The 1 did not work out for me. So I'm now going to just cross it off. I'm not going to write no solution because 6 is the solution.